Good day, everyone. Let's have another topic to discuss for this meeting or for this period of time. So we have here solving quadratic equations by extracting the square root, by factoring, by completing the square, and by quadratic formula. So all of these methods are being discussed in this instructional video and is prepared by Seth Kersley May Sinangotti, again saying hello learners. Before we all go through the different methods, let's have first the definition of a quadratic equation. So we don't have to worry, this is just a brief review of what a quadratic equation means. So it is a second degree equation where the term with the variable with the highest exponent is of degree 2 and is in the form of ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a is not equal to 0. For example, 2x squared plus 4x minus 6 is equal to 0. So as you can see from the equation, it is in its standard form, and 2 is the highest exponent of degree 2. Let's have the expressions x squared is equal to 12, x squared is equal to 25, and x squared is equal to 10. So these are the simplest forms of quadratic equations. Now, how to get the solution of such quadratic equations? Then our first method comes. We have by extracting the square root. How is this done? So by extracting the square roots, let's say x squared is equal to 25. The first step is to extract the square roots of both sides. So we have square root of x squared is equal to positive negative square root of 25. Since square root of x squared is equal to x and square root of 25 is equal to 5, we now have x is equal to positive negative 5. So the roots of the equation x squared is equal to 25 are positive 5 and negative 5. Easy, isn't it? Let's have our next example. We have x squared minus 169 is equal to 0. By addition property of equality, we can now have x squared is equal to 169. So extract the square roots of both sides. We now have square root of x squared is equal to positive negative square root of 169. Since square root of x squared is equal to x and square root of 169 is equal to 13, we now have x is equal to positive negative 13. Thus, the roots of the equation x squared minus 169 are positive 13 and negative 13. Our third example, we have here 8x squared minus 192 is equal to 0. By addition property of equality, we can have 8x squared is equal to 192. By division property of equality, we divide both sides by 8 to cancel 8 on x squared. So we have x squared is equal to 24. We extract the square roots of both sides. We now have square root of x squared is equal to positive negative square root of 24. Since square root of x squared is equal to x and square root of 24 is equal to 2 square root of 6, but why did it become 2 square root of 6? Since square root of 24 can be factored out into 6 times 4, and 4 is a perfect square, so we can simplify it into 2 square root of 6. That's why it became positive negative 2 square root of 6. Thus, the roots of the equation x squared minus 192 is equal to 0 are positive 2 square root of 6 and negative 2 square root of 6. So that is the method extracting the square roots. Let's now proceed to our next method. We have by factoring. So first is we have to know the steps in finding solutions by factoring. First step, we have transform the equation into its standard form. So when we say standard form, we have ax squared plus bx plus c is equal to 0. The next is to factor the left side of the equation. So if we have the standard form ax squared plus bx plus c is equal to 0, we factor the left side, which is ax squared plus bx plus c. The third step is to use the zero product property or ZPP. So this property states that for any real number a and b, ab is equal to 0 if and only if a is equal to 0 and b is equal to 0. In the last step, we have solve for x. Let's have our first example. We have x squared minus 2x is equal to 15. So our solution transform into its standard form. So what is the standard form of this equation? We have x squared minus 2x minus 15 is equal to 0. Next step, factor the left side of the equation. But how? So first thing is, we have to find the factors of negative 15. And we have 5 and negative 3, negative 5 and 3, 15 and negative 1, negative 15 and 1. If you multiply these factors, it will result to negative 15. The next thing to do is to find the factor that will result to negative 2 when added. So let's have 5 and negative 3. If we add 5 and negative 3, it will result to 2. If we also add 15 and negative 1, it will result to 14. Negative 15 and 1 will result to negative 14. Negative 5 and 3 will result to negative 2. Thus, we have negative 5 and 3. So now we have the factor of x squared minus 2x minus 15. We have x minus 5 multiplied to x plus 3. So let's now use the zero product property or ZPP. Thus, we have x minus 5 is equal to 0 and x plus 3 is equal to 0. Let's find the x of each product. We have x minus 5 is equal to 0 and x is equal to 5. We have x plus 3 is equal to 0. Thus, x is equal to negative 3. So, to check, we just substitute 5 to the original equation. We have 5 squared minus 2 times 5 is equal to 15. Since 5 squared is equal to 25 and 2 times 5 is equal to 10, by simplification, 25 minus 10 is equal to 15. So we have 15 is equal to 15. Thus, the equation is true. Let's have at x is equal to negative 3. So the same thing, we substitute negative 3 to the original equation. We have negative 3 squared minus 2 times negative 3 is equal to 15. We manipulate the equation. We have 9 plus 6 is equal to 15. Thus, 15 is equal to 15. So the roots of the equation x squared minus 2x is equal to 15 are 5 and negative 3. Let's now have the third method, which is using completing the square. So in using this method, we aim to produce a trinomial that is a perfect square. We take note that a perfect square trinomial can be expressed as the square of a binomial. For example, x squared plus 4x plus 4 is equal to x plus 2 squared. And x squared minus 6x plus 9 is equal to x minus 3 squared. Note that these quadratic trinomials are still of the form ax squared plus bx plus c is equal to 0, where a is equal to 1. Moreover, the constant term in every perfect square trinomial is the square of 1/2 the coefficient of x, or b halves squared. If we add b over 2 squared to the expression x squared plus bx, then we have x squared plus bx plus b over 2 squared is equal to x plus b over 2 squared. For example, x squared plus 10x. So, using b over 2 squared, where b is equal to 10, where did we get 10? So, it is from the coefficient of our x. So, we have 10 over 2 squared is equal to 25. Thus, we add 25 to x squared plus 10x. So, we have x squared plus 10x plus 25. And we make the right side of the equation into a square of a binomial. So, we have x plus 5 squared. Let's now have an example of an equation where we can find solutions using completing the square. So what are the solutions of the quadratic equation? 2x squared plus 5x minus 3 is equal to 0. First thing to do is to place the constant 3 to the right side of the equation using addition property of equality. So we have 2x squared plus 5x is equal to 3. We divide both sides by 2 so that the coefficient of x squared is 1. Now we have x squared plus 5 over 2x is equal to 3 over 2. Complete the square by adding the square of half of the coefficient of x. Since our coefficient of x is 5 over 2, so we use 5 over 2 as our b. Now we have 1/2 times 5 over 2 squared. 1/2 times 5 over 2 will result to 5 over 4. And 5 over 4 squared will result to 25 over 16. So we add 25 over 16 to both sides of the equation, and it will become x squared plus 5 over 2x plus 25 over 16 is equal to 3 over 2 plus 25 over 16. The next step is to write the left side as the square of a binomial. Okay, so the square of a binomial of the equation x squared plus 5 over 2x plus 25 over 16 is x plus 5 over 4 squared. And 3 over 2 plus 25 over 16 is equal to 49 over 16. So extract the squares of both sides. As you can see, we are also using here the extracting the square root method. So we now have x plus 5 over 4 is equal to positive negative square root of 49 over 16. We now have x sub 1 is equal to negative 5 over 4 plus square root of 49 over 16. And to simplify this equation, we have x sub 1 is equal to 1/2. And our x sub 2 is equal to negative 5 over 4 minus square root of 49 over 16. For simplification, we have x squared is equal to negative 3. Thus, the roots of the equation 2x squared plus 5x minus 3 is equal to 0 are 1/2 and negative 3. Let's now have our last but not the least method, which is using the quadratic formula. So to use the quadratic formula, we have to whiz. What is whiz? So first is the w, which is write the given equation in its standard form. As we all know, the standard form is equal to ax squared plus bx plus c is equal to 0. The next is the I. Now what is the I? So it is to identify the values of a, b, and c. And lastly is the s, which is to substitute them into the quadratic formula. But what is the quadratic formula? So the quadratic formula is x is equal to negative b positive negative square root of b squared minus 4ac over 2a. Take note that for real solutions, we assume that b squared minus 4ac is greater than or equal to 0. That expression b squared minus 4ac is also called the discriminant. Let's now have an example. Solve the quadratic equation 4x squared is equal to 2x plus 1 using the quadratic formula. So our solution, first step is to transform into standard form. So what is the standard form? We have 4x squared minus 2x minus 1 is equal to 0. The next thing to do is to identify the values of a, b, and c. So the value of a is equal to 4, the value of b is equal to negative 2, the value of c is negative 1. So substitute them into the quadratic formula, which is x is equal to negative b positive negative square root of b squared minus 4ac over 2a. So we have x is equal to negative times negative 2 positive negative square root of negative 2 squared minus 4 multiplied to 4 and multiplied to negative 1 over 2 times 4. We simplify the equation. We now have x is equal to 2 positive negative square root of 4 plus 16 is equal to 8. So simplify still the equation. We have x is equal to 2 positive negative 2 square root of 5 over 8. So what happened? Why did it become 2 square root of 5? We all know that square root of 4 plus 16 can be simplified into square root of 20. And 20 can still be factored into 4 and 5. And 4 is a perfect square. So we can say that square root of 4 plus 16 is equal to 2 square root of 5. So to simplify the equation, we have x is equal to 1 positive negative square root of 5 over 4. Thus, we have our x sub 1 is equal to 1 plus square root of 5 over 4. And x sub 2 is equal to 1 minus square root of 5 over 4. Okay, so those are the methods in solving quadratic equations. So we can say that quadratic equations can be solved by extracting the square root, by factoring, by completing the square, and by quadratic formula. We just have to remember the steps on how to solve quadratic equations using the methods. As for the quadratic formula, we have to remember that the quadratic formula is x is equal to negative b positive negative square root of b squared minus 4ac over 2a. That's all for our discussion. Thank you for watching. Hopefully, you've learned something good and another learning has come to you by watching the instructional video.